In the last video, students, we collected our data and we have our data set here. And now we're just going to share this with Microsoft Excel via graphical. So under graphical, of course, we want to switch our data source over to a table. And then we're going to share that table with Microsoft Excel. So if it doesn't open up the first time, well, it looks as though it's opening up this time. So it didn't really save this time. So I'm going to go back and do the same thing again. And I'll open in Excel. So now I'm just going to convert and edit this and make sure that I put this into the appropriate folder here. Oh, what is it saying? Oh my goodness. I got to sign in. So let me just sign in real quick. I don't see why I have to do that, but let's see, go to Brass, Eric, and Conservation of Energy, and then I just want to save it there. So now I have my data saved here. I am going to do something that might be a little disturbing to you guys. I want to go back to my folder, take it to its original state as I have been working in it. And so you'll see that we have a COE. I need to get rid of this file, and I need to get rid of this file. So you guys shouldn't have to do this. Everything else should be pretty much the same for you guys. I have notes in there and everything. And so let me just go back. Well, I should stay in there. But I need to go back to Microsoft Excel. And I want to dress up this data a little bit. I want to see what we have here. So you'll see we have analysis, time, X, Y, and then X velocity and Y velocity. So I'm going to select on time, hide that, select on, oh, we don't need X, so I'm just going to, I need to hide both of these. Time, A and B, I just unhid A by accident, and then the X and Y velocity, I need to hide both of those. So we have a nice data set. Let's just go ahead and look at this. We have 0, 44, 0, 45, 0, 46, 0, 45, and what I'm looking for is duplicates. So I don't see any duplicates. 0, 45, 0, 40. Oh my goodness. Now I've just deleted some data. Okay, 0, 46, 0, 44, 0, 45, and 0, 45. So that's what we need. And the way you're going to be able to tell is if you go into that Dropbox folder, to your Dropbox folder, go into Conservation of Energy. You'll see the template here, Conservation of Energy, last name, first name. And we should see some data here. I'm just going to take this data out. This is the data that I had from a previous experiment, so I'm just going to clear that. Now I want to go back to that particular data set, and I'm going to place my data into that particular file. So here we go. I'm going to grab one C, Copy, go back to the conservation of energy, last name, first name. And then we just want to paste this in. So you'll see that all of our displacements are positive and they're around the same value. You'll see no zeros, you see no negatives. We have our average displacement. We have our initial velocity in the our initial velocity according to the conservation of energy. And then this is my kinematic, my initial velocity due to the kinematic equations. And how did I find that? Well, what you want to do is you want to actually go to Dropbox. You don't necessarily have to do all of this. It's easy just to type it in, but I kind of like to group all the documents together. So I'm just going to select on this document right here, which is, and I'll look at it real quick. This should be my calculation for the initial velocity, and it is. If you notice, we have 3.1 right here. So I'm just going to copy that. I'm not going to move it. I'm going to copy it. And I want to move it to conservation of energy. So I'll just paste it right here. So if I go back to the conservation of energy, you will notice that I have the data set, conservation of energy, and you have your initial velocity here. And we have 3.1. So if you don't know what your initial velocity is for the kinematic equation, it's right here under this file that you just moved over. So if I go back into Microsoft Excel, that is why I have 3.1 right here, and I have a percent difference of 3.62. So firing the ball straight up and shooting it straight out gives us a difference of about 3.62. So if we can agree that that error is acceptable, we are good. Make sure that you share this folder with me, and that'll be the end of this portion of the experiment, or this experiment.